Okay, so moving on with the chi-square, we did the null and alternate for the goodness of fit test. Okay, so now we're going to move on to the actual finding the p-value and coming up with a conclusion. So the goodness of fit test has just one variable, and we're looking if that variable fits a given distribution. The example we looked at for the first null and alternate was the roulette wheel. A roulette wheel has 3 different colors on it, and each color has an equal chance of getting hit. Test the claim being 95% confident. And it showed me the observations then, red, black, and green with the numbers. We came up with our null. The distribution of colors is uniform. This is going to be very important. That equal chance is extremely important for this situation. And the alternative is at least one is not equal to the rest. So again, there's step 1, your null and alternate. By now you should know I'm sending them back and unsubmitting your assignments if you don't have your null and alternate to start your problem. So make sure you have your null and alternate. And now we're not getting into calculating the test statistic. The test statistic and the p-value. So I'm going to go just get rid of some of this, and there's our observations. To get the test statistic, this is unfortunately there's not one function on your calculator to calculate the test statistics for the most part. So we're going to have to go through the steps to finding it using some shortcuts I'm going to show you on the calculator, but this one takes a little bit more work than the one sample test and the contingency tables where you could just use the matrices. The formula for the test statistic is going to have x squared as the symbol for it, so that's what we're going to be using as our symbol when we write it out in our final answer. The formula is observed minus expected squared divided by expected, and this symbol right here is a summation symbol. You would add all those together. We're not going to be doing each one. You would have to do that depending on how big the list is. That's how many times you would have to do it. We would have to do it 3 times in our situation. Wouldn't be horrible to do, but I'm still going to show you a shortcut how to speed that up a little bit. What we do need is the expected. We're given the observed. 141, 150, and 9 are our observed values. That's what actually happened. What we would expect to happen, that's what we would have to calculate. Now, we're saying that each color is going to show up evenly. They each have an equal chance, and that's why that's important to know what we think our distribution is. So to get our expected values, what we would think would happen, first we have to find the total of observations we're looking at. So our total observations, just adding them up, gives us 300. And if this was evenly distributed, we would just have to split up that 300 in the 3 sections. So there's 3 categories, so 300 divided by 3 is 100. Our expected values, they each correspond, so each observation has to have an expected value. Those are going to be our 2 lists that we're going to work with. For each one of these, you should have to do this formula. Observed minus expected squared divided by expected. I'm going to show you how to do it on the calculator, a quick little shortcut in a second. Before I go to the calculator though, the other thing we're going to need is something called degrees of freedom. Now I've been skipping this a little bit because we kind of been summarizing and really shrinking down the curriculum. The degrees of freedom is something that we're going to use to calculate our p-value. The degrees of freedom is going to be n minus 1. Now big N counts for how many categories there are. So in our situation, 1, 2, 3 categories. 3 minus 1 is 2. So there's the information you need. You're going to need your 2 lists, and you're going to need your degrees of freedom. So I'm going to go to the calculator. And the first thing we need to do is enter our list into L1 and L2. So we've done this a couple times. Stat, edit. My lists are all cleared out. I'm going to plug them in real quick. 141, 150, and 9. Go over to L2. This is our expected, and each one of our expected was the same thing. It was 100 each time. Okay, so there's our observed, there's our expected. Second quit. Now the formula was observed minus expected squared divided by expected, and then adding all those up. Do this quickly on your calculator. There's not one function, but you can plug it into the equation. First I'm going to hit second lists and go over to math. And number 5 on my calculator is the sum. This is going to be doing the adding for us. So I'm going to go to number 5, the sum, parentheses, L1 minus L2, close parentheses, squared, divided by L2, close parentheses. This is doing the exact formula for the test statistic. L1 minus L2 squared divided by L2. And then the sum in front is adding all those together. So if I hit enter here, 124.62. There's our test statistic. So you want to write that down, label it as test statistic or x squared, because that's going to be needed. The next thing we have to do is take that test statistic and we need to calculate the p-value. Our p-value is going to be using the chi-square distribution. So we used normal CDF when we were doing the normal curve, and we use this distribution function over here on the calculator. So I'm going to go back to that menu. Second, distribution, and on my calculator it's number 8. It's x squared, that's the chi-square symbol, chi-squared CDF. So I'm going to go down to number 8. Make sure you're doing CDF and not PDF. And it's going to ask for 3 things: lower, upper, and DF is our degrees of freedom. So I'm going to plug in lower and upper. Now this is a newer calculator. The older calculators, you might just have to write it out with commas in between, which I'll show you how that looks like in 1 second. So I'm going to first plug in my numbers. 124.62. Some just obnoxiously big number. Okay, so just 99999 would be fine. Our degrees of freedom was 2. And it's asking me to paste. And this is what it would look like. This would show up right away on some of the older calculators. You just need to type it in as your lower limit is our test statistic, comma, obnoxiously big number, comma, and then degrees of freedom. This is going to give us our p-value. So if I hit enter here, 8.69182218 e to the negative 28. Again, that e to the negative 28 means some extremely small number, so we can round that to 0. So our p-value in this case is going to be 0. Okay, so I'm just going to go back to my PowerPoint here. We found the expected value. We found degrees of freedom. We went to the calculator and found our test statistic and our p-value. And now let's write out our final answer. So step 1, we have our null and alternate. The distribution of colors is uniform, meaning red equals black equals green. At least one is not equal to the rest. Our alpha level was 0.05 because we were 95% confident. Our test statistic was 124.62. Degrees of freedom was 2. And our p-value was 0. We rounded our p-value to 0 because it was at e to the negative 28. And now we're coming up with the conclusion the same exact way. Since our p-value is less than our alpha level, we would reject the null. And since we reject the null, that means we're siding with the alternative. There is at least one color that is not equal to the others. Green looks much lower than red or black, which it did. Green was at only 9, where red and black were at 141 and 150. Look at the screen. This is what your answer should look like. I need all 4 of these values: alpha level, test statistic, degrees of freedom, and your p-value. I need your null and alternate. That should be your first step. And then your conclusion should not be far off of what I have here. The first line is telling us if we're going to reject or fail to reject and why. The next line is just explaining the meaning to that. Okay, so this screen here, this is what your final answer should look like. And just a quick little reminder, the steps to finding p-value. You found the expected values. We did 300 divided by 3 to get 100 for each one. You entered the list into your calculator to L1 and L2. We found the test stat by doing the formula sum, L1 minus L2 squared divided by L2. Found the degrees of freedom, which is n minus 1. And then the test statistic, which is x squared, comma, an obnoxiously big number, and then the degrees of freedom. Okay, so there are the steps. You know what the problem and the answer should look like. The next example, Finding the expected values is going to be different for each problem, so please watch the next example and see how the expected values are calculated for that one.